In the first one, the ball is projected at 45 degrees, and this is 25 meters per second. And my question is, I would like to know, how far does it travel on the range, the ground? So I want to know what is the range.
This is number one?
My first example, we'll call it example A.
Nothing is
Oh no, I'm making these up. Okay, so, Grace, what is this part and what is this part? Yeah, so it's 25 cos 45, and then what's this one? 25, 25 sine 45. Okay, so the two numbers here are 25 cos 45, this will be 17.7 meters per second, and then 25 sine 45, this will be 17.7 as well, meters per second. So if I want the range, first thing I should always do is get the time. So do I look at the x or do I look at the y?
X.
Y first. Yeah.
Range.
For range, you have to get the time first, which you get from the y. So what's the u? 17.7. What's the v? Don't know. What's the a? Minus 9.81. What's the t? Don't know. What's the s? You do know.
S. Something because you can get.
You do know it.
Yeah, it will be 20.
Nobody can tell me what the s is. 0.
It's displacement.
It's displacement, and at the end, it's on the ground. So it has no vertical height. Yeah.
Just so I know 0 with a question, like an example.
But you know it's 0 because I say, how far does it travel? So at the end, what's its height? What?
How far it travels.
Yeah, but first I need to get the time. Then I will get the distance it's traveled. So the way to find the time is by looking vertically.
You're looking.
Yeah. Yeah. So what formula can I use here? S equals ut plus a half at squared. S equals ut plus a half at squared. I can cancel the t's here, so I get the time is 3.61 seconds. Okay, now I can get the range. So what's the u? 17.7. What's the v? Don't know. What's the a? 0. What's the t? What's the t? 3.61. And the s is what I want, which is u t plus a half a t squared, so there's no a. And this is my answer. 63.9 meters.
What's equal range?
Range, yeah. Yeah. Yeah, these are all going to go up on the web page. Okay, the B part. Sorry, can I scroll down?
Yeah.
I think my B part one I said was going over a cliff, wasn't it?
Yeah.
Yeah.
Is
So,
it right?
with an extra height, yeah. So actually, maybe I'll do the C part next, since it's a little easier. So, I don't know, Batman or someone. And he's running straight across here at a speed of, I don't know, 10 meters per second. And let's say this here is 10 meters high. So my question is, how far does he go? Yeah, so let's have a look at the X and let's have a look at the Y. So firstly, the Y. What's U?
Why?
Zero.
Very good, Amanda. V?
No.
Don't know. A? Minus 9.81. T?
No.
Don't know. S? Minus 10. He goes down 10 in the Y. Right, so what formula? Good old S equals UT plus a half a T squared. And I got here T equals 1.43 seconds. Now I can use that to get the range. U, what's U? If you have to look at the picture, what's U? 10. V, don't know. A, 0. T, the answer I got here, 1.43. And S is what I want. So S equals U, T, plus a half a T squared, which is gone. So again, I have my range. It will be 14.3 meters.
And why use equals 0?
Because Batman is running horizontally. He doesn't jump. There's no vertical speed, just horizontal. Yeah. Okay. Can I go on?
Yeah.
Yeah. Okay. Part 2, Return of the Dark Knight. So this time now, Batman is still going at 10 meters per second, but this time he jumps at an angle of 30 degrees. So once again, let's calculate, for example, what is the range. So before we calculate it, will it be more or less than the last part? What do you think? A bigger or a smaller number than what we got in part C?
The range?
The range.
Small.
We think it should be smaller. Right. My friend Grace, how big is this one? Yep. You know?
10 cos 9
Yeah, okay, so let's see. 10 cos 30? This is 8.66 meters per second. And then here, 10 sine 30? This is 5 meters per second. X, Y. Okay, U, V, A, T, S. The U, what is it? 5. V, don't know. A, no, we're looking vertical, minus 9.81. T, don't know, and S, this is still 10 meters.
You said B is equal to 0.
Oh, sorry. Ridiculous. B, we don't know. Okay, so let's get the time. S equals U T plus a half a T squared. So I can change this into a quadratic. I can use my quadratic formula. A equals minus 4.905, B is minus 5, C is 10. You know, just do what we did in math class, and you get two answers for T. Oh wait, hang on.
You take positive.
You take the positive one. Is that that's a minus 10 now? Minus 10. I took them to the left. So the first answer is 2.03, and the second answer is minus 1. So we'll forget about the negative answer. Okay, U is 8.66, T is 2.03, and S is UT. Is there any acceleration? Horizontally? No. A is 0. So, 2.03 times 8.66. And I get S equals 17.6 meters. What did I get last time? Right, it's bigger. That's not right. Did I keep everything the same? 10 meters, 10 meters.
143.
Oh, it's bigger. That's surprising. Does that make sense?
No.
8.66 times 2.
What's the new one?
Ah, it's bigger. That's weird. We would have thought it was smaller. But actually, I know why it's bigger. Why is it bigger?
Where is it?
Here, this is the range.
17.6.
Yeah.
That's smaller because we have 143.
No, that's 14.3.
Yeah.
Why is the range bigger? We all thought it should be smaller.
Yeah, because
I think it's bigger because when he jumps in the air, he's in the air longer. So he could go further. Yeah. In fact, sorry, of course the range is bigger. And in fact, not only is the range bigger, I can tell you what angle he should jump at to make the range biggest. Does anyone want to have a guess?
45.
Yeah. If he jumped at 45 degrees, this would actually give him the most range. Yeah. So, we all thought it'd be smaller. That's wrong, totally wrong. It gets bigger, and if the angle is 45 degrees, this gives them the most range. Can you look? If the angle is small, you just go like this. I'll draw it again. If the angle is small, you'll go like this. If it's 45 degrees, you'll go like this. But if the angle is too big, you'll just go straight up and come back down.
but teacher, 45 will be smaller.
No, 45 works out to be the angle that gives you most distance.
More distance.
Yeah.
Okay, it's 30.
Less than
Less than 45.
Less than 45, yeah. And if it was, say, 60, that would be less than 45 as well. In other words, this maximum range here happens at 45 degrees. When we were at 30 degrees, it's less than this.
Okay, teacher,
Yeah.
180.
180?
Yes.
That means he jumps this way.
Yeah, but like the distance would be.
The distance would be negative. He's going backwards. Yeah. Yeah. So we want to keep it between 0 and 90. Otherwise, if we're more than 90, it's going backwards. Yeah. Okay. That was 3 examples. So one more example. Can I go down?
Yeah.
Right. Sure. Let's go back to Batman since we're on a roll with him. So this time he jumps straight up at 90 degrees and comes straight down. So my question is, how far does he travel? His distance. So we need to do it in 2 steps. First we need to calculate this distance, and in fact we already know this distance here. What is it? What's this distance here? It's the same as before. What is it?
0.
No, the distance. 10 meters. Okay, so let's look at this journey here. Let's work out the time for him to get to the top. What's U? V-A-T-S. What's U? 10. It's the same man. It's still Batman. It's 10. What's V? 0A? T? Don't know. S? Don't know. What formula will we use? We'll use V squared equals U squared plus 2AS. So I get S equals 5 meters. 5.1 meters. So what's the total distance he travels? It will be 5.1 plus...
10 meters.
No, be careful.
5 into 2 and then...
5.1, 5.1, 10.
Up, down.
Up, down, and down. Up, down, down. Okay, are we feeling a bit better about projectiles? We feel better about projectiles. So then on Monday, we can check those projectile homework questions. You should have more luck this time. But before we go, I want to do another drag example. Okay. Okay, so this here is some oil, and I haven't fallen through it, and we're making 60 kilograms. Yeah, the end of that then. So, right, so what I want everybody to do for me is, let's say this here is 20 meters. What I want everybody to calculate for me is, if there was no oil, how long until he hits the ground? If there was no oil. So he starts here, and then he starts to fall, and then he hits the ground here. If there was no oil, how long until he hits the ground? Is that yours, Jamie? Yep. Okay, so you should be doing something with projectiles for this, really, UVATS. Oh, this could be the end. I'll have to use my mouse, so I apologize. What did you get? 2.02. What did you get? No calculator? Okay, U is 0. B we don't know. What's A? This will do. You can read it, can't you? What's A? 9.81. T is what you want, and what's F?
20.
Minus 20 if you're going to use minus for the A. Okay, so can you calculate the T, and we'll trust KJ, what did you say the T was?
2.02.
And you use this information? Yeah. 2.02.
There's no, oil?
If there's no oil, he just falls. Now, there is oil, and when the oil is there, it takes them 3 seconds to fall. It takes them longer because there is a drag force. Okay? So my question is, if it takes them 3 seconds to hit the ground, how much drag force is there? That's my question. So before you do that, calculate his weight. What's his weight? What's the formula for weight? mg. So can someone tell me what's mg here? Yami? Oh, what is it? 588.6 newtons. Not working. Okay, that's his weight. Now, it takes 3 seconds, so is the A the same? Is it the same A?
No.
No, it's different. So can you calculate the new A? You can use U. What's the T now? I said it's 3 instead of this. Okay, can you tell me what the A is? Can you calculate it? So U is 0, T is 3, and S is minus 20. Give me the A. It should be less than 9.81.
4.4.
Oh, it's a lot less. Which formula did you use?
S equals UT.
Okay, so you got A is 4.4 when you did that. Okay, so now calculate the F by using F equals MA. What is it? So this F is, I'm really sorry about this, 264 newtons. Okay. Now, second, that 264 newtons, what does that represent? Is that the drag, the driving force, or something else? Nope. The driving force, what's making him fall? His weight. How much is his weight? 588 newtons. So this is the driving force. What's going up? The drag force. When you combine them together, you get the total force F, 264. So that 264 is 588.6 minus the drag. Yeah, so now tell me the drag force. Calculate it. You typed it in? Yeah, so it's minus because it's going up. What did you say it was? 3?
Minus
324.6 up. So I'll just write D for drag. What did you say? 324. Yeah. 324. Huh? 3/5? Oh, you're saying what's 3/5? Oh, the fraction? Oh, no, I'll leave it as newtons. 324.6. Oh, yeah. Yeah, well, 0.6, okay. Yeah. The pen stopped working. So, we've done more examples of projectiles. So actually, what did we do? We did all the drag homework questions, 2 projectile homework questions. Don't pack up, don't even think about packing up, KJ. I'm still talking. Open up your book. Open up the book. Thank you. Don't pack up, just listen. So we did all the drag homework, 2 questions on the projectiles homework, 4 more examples of projectiles, and 1 more example of drag. So on Monday, I want to check your drag homework and your projectiles homework. And I'll do the projectiles homework on Monday. If there's still problems with these, you must let me know, because I'm just going to continue with the next topic. Okay? So I want to make sure you're happy with this. But you have some homework tonight. Listen to your homework. Listen carefully to your homework. Your homework is to do the projectile questions, do the drag questions again by yourself without checking your answers. Then you can check your answers afterwards.
Which?
Do the drag homework again. Again. Do the projectile questions for homework.
I want to write the drag one.
If your answers match up, do it again. Do the projectiles homework, and I will check this tonight. Tonight, I want everybody... Tonight, yes? I'm still speaking English, haven't I? Yeah? So tonight, I want you all to watch the projectiles lesson and the weight lesson again. Tonight. I will log on to Moodle and check that you've watched it. I can do that. I'm the Moodle administrator. I can do this. Alright? So tonight, what do you need to watch? The Moodle, projectiles and weight. And then on Monday, what will I check for your homework? The drag weight homework and the projectiles homework. Are we clear?
Yeah. Because the last time...
Are we clear?
Yeah.
Any questions? What's your question?
The last time you checked the homework?
Yeah.
We did the drag one.
But I want you to do it.
I got the right.
I want you to do it. Say again? That's right. Because they're difficult.
Oh, I got the right.
Yeah, but do it again and see if you still get it right. Okay? Maybe you forgot how to do it. You know, you work too hard, you're stressed. I don't know.